Hello, my name is Kevin, and welcome to The Structure of Climate Risks and its Implications for High-Impact Climate Philanthropy. I'm excited to introduce you to Johannes Ackva. Johannes is part of the research team at Founders Pledge, bringing 5 years of experience working in a think tank advising decision makers on climate policy. He's also researched the intersection between effective and feasible climate policies. He holds Master of Arts in Social Sciences from the University of Chicago and Masters of Science in Sociology with a focus on research methods from the Interuniversity Centre for Social Science Theory and Methodology at the University of Groningen. Today, Johannes will be discussing the distribution of risks suggested by current climate predictions, as well as how our time and resources can be best allocated to deal with the most severe of them. We invite you to use the SwapCard platform during the session. On the right side panel, you can feel free to share your thoughts on the live discussion board and leave and upvote any questions for our speaker to answer at the end of the presentation. After the session, we also invite you to use SwapCard to set up meetings with future conference attendees. And without further ado, welcome, Johannes.
Yeah, thank you, Kevin, for the nice introduction, and welcome everyone to this talk. And what I really want to talk about is kind of how to deal with climate prioritization in an uncertain world, and how, when we're actually facing a very confusing situation with lots and lots of uncertainties, both around climate risk, how many emissions will there be, how much warming will there be per emission, how much damage is there per warming at different levels, and also with uncertainties about climate action, will the Paris Agreement continue or will it break down at some point? Which technology will succeed? And how will kind of climate policy support develop? So in the situation where we're like facing extreme levels of uncertainty across lots and lots of different variables, I kind of want to talk about how actually what we know about how those different uncertainties relate to each other can actually help us make much better philanthropic bets at the margin. So like make bets that are high impact, even though we're in a situation of very severe uncertainty. And to kind of start out, I want to characterize how climate risk looks like, the structure of climate risk, which is kind of the first part of this equation. Like, how does climate damage and climate risk actually look like? And to really understand climate risk, we want to understand how climate damage is distributed over different possible climate futures. So we can see this here. So what we want to get at is a distribution of expected damage, which is a function of both how likely different temperature scenarios are and also how much damage there is in those different climate futures. That's kind of what we try to estimate here in this first part. And what does the literature actually have to say about this? So first, let's start with the probability of different warming scenarios. And luckily, there's now an emerging literature on forecasting the distribution of climate outcomes. The best on this is probably Lee and Raftery 2021. Unfortunately, I only got the data for this morning, so I'll have to include that analysis in the write-up later. But I'm using the predecessor, which is Raftery et al. 2017 for the probabilities. And importantly, some of you who've been following this discussion in EA or otherwise maybe know the Wagner and Weizmann probabilities in climate damage, which estimated something, in climate scenarios, which estimated something like a 10% probability of more than 6 degrees. So these probabilities that I'm going to show you now are actually quite different and quite a bit more updated, so kind of supersede those. And yeah, this is kind of how the warming distribution looks like in Raftery et al. 2017. So what we can see, or what I would briefly want to highlight, is there's about a 5% chance or so that we'll kind of reach the goals of the Paris Agreement, so have like 2 degrees or less of warming based on their predictions. And interestingly, the chance of over 6 degrees of warming, so 6.5 or 7, is something like 0.6%. So it's more than 20 times lower than Wagner and Weizmann suggested in their work. And yeah, if we kind of look at the most likely climate futures, so they're kind of starting at 2.5 degrees and then 3 and 3.5 degrees. Yeah, so that's kind of how it roughly looks like. This is kind of what we're going to take as how likely are different climate futures. Then there's, of course, the question, like, how damaging are different climate futures? And for this, we have the integrated assessment model literature as kind of one of the literatures that tries to answer this question, where they have damage functions like the ones that you can see on the right here, where usually the finding is, or the model is, that climate damage is highly nonlinear. So if you kind of think about 6 degrees here, the implied per GDP damage at 6 degrees it's much larger than twice as large than the damage at 3 degrees. And so it gets ever more extreme. So these models usually suggest that climate damage is very nonlinear. Higher degrees of warming are much more important to avoid. And this kind of intuition seems also consistent with, I think, how we think about indirect risks or social knock-on effects. We think about grievances, etc., other or conflicts that might arise out of climate impacts. We would, I guess, often think that at some point there's adaptation, then there kind of comes a point where adaptation is harder and where more of the risk is concentrated in higher warming futures. And I think it's probably also the long-termist intuitions insofar as we think of climate as an existential risk, which I'm not suggesting it is, but like kind of if we're saying it's kind of there is an indirect existential risk of threat multipliers, etc. And so far as that exists, it's certainly in the tails and the higher warming scenarios. So that's kind of a large part of the literature. I do want to point out that it's not entirely consensual. This is not like there's no. It's not that there's no discussion about whether climate damage is linear or nonlinear. So there's one important outlier study that I want to focus on here, or that I want to at least introduce here, which is Burke et al. 2015. And what they're kind of finding is, first of all, a much larger climate damage, but also climate damage that's much more linear over different temperatures. But it's important to point out that actually using this model and cross-validating it across different contexts, it did actually not perform well. So this is why I'm not taking this as particularly strong evidence, but it's kind of part of the overall credence. So kind of bringing those things together, what I'm kind of working with for the rest of this talk is a damage function that looks like this. So it's clearly nonlinear, but it's not like the most crazy nonlinear specification. It's kind of fed from a normalized damage function, which is 75% from the integrated assessment models and 25% from the linear specification from Burke et al. So this is kind of what we're kind of going to work with for the rest. And now that we kind of have a best guess both on the probability of different warming and kind of on the damage, we can kind of generate expected climate damage, so probability weighted climate damage essentially. So this is what we're have here. And I think there's two things here again that I want to highlight. One is that there's very little expected climate damage in the kind of the worlds that are kind of targeted by the Paris Agreement, 1.5 to 2 degrees, which is a combination of those worlds being unlikely to be achieved. So like before we had like a 5% chance that we're in those, but also that there's very little damage here. And then another kind of important finding, especially if we think about the earlier Wagner and Weizmann studies, etc., is that even though climate damage is highly nonlinear because the probabilities are decreasing rather steeply after 5 degrees or so, so it's not true anymore that all of the damage, all of the expected climate damage is in the right tail. Rather, most of the damage is kind of in the world's like 3.5 and 5 degrees or so. That's kind of where most of the damage is concentrated, because those worlds are both reasonably likely and reasonably damaging. So why does this actually matter, and how does this actually help? Why is this not an entirely academic exercise? The reason that this matters is because knowing, quote unquote, where we end up with regards to our climate future helps us to resolve lots of other uncertainties. So to make this concrete, let's just like focus on 4 different things that we're currently pretty uncertain about and that have implications about what we should do as climate philanthropists. One of them is, will the Paris Agreement remain intact? Will we have strong international climate policy? Let's say it's 50% yes, 50% no. Another is kind of what should we assume about the trajectory of renewables? Will the renewables continue to exceed all expectations, or will they at some point kind of plateau, relatively speaking? Let's say 65% continued success, 35 less. And then will emerging economies kind of grow to the same level of economic development and energy consumption as the developed world right now? Let's say probability that they don't is much smaller here, is only 20%, 80% yes, this will happen. And then let's say we are uncertain about what the current level of energy innovation efforts, which have certainly ticked up, what they will imply in terms of innovation down the line. Will they produce sufficient innovation? Let's say that's 1/3, 2/3 no. We're pretty uncertain about all of those things. But, and that's really the key finding here, when we're kind of in the world of 4 degrees or not, we can be pretty sure that how most of those uncertainties have resolved. First of all, if we're in a 4-degree world, we can be pretty sure that climate policy as we know it, the Paris Agreement, has broken down because it's kind of outside of the scope of climate sensitivity variability. So like it's pretty clear that something must have happened that has pretty much ended climate policy as we know it. It's also pretty unlikely that we're ending in that we're in a world where renewables have continued to exceed all expectations, because otherwise carbon intensity would be much lower and we wouldn't reach that many emissions. Similarly, it's much less likely that we have avoided lots of energy intensive growth in emerging economies. And it's also much less likely that we've just produced all of the energy innovation necessary with the effort that we already had spent on this. So essentially, we can learn from future failure. And that has fundamental implications because we can kind of make bets that take this into account. But before we look at those bets, let's first kind of look at the major bets that climate philanthropy is making right now. Mainstream climate philanthropy, it's essentially 3 big bets. The first is on renewables, the second is on natural climate solutions such as forestry, etc. And the third one is building public support for more climate action in the United States, particularly. So by and large, all of those bets kind of bet on good outcomes for a relatively small set of solutions or approaches. And yeah, to kind of illustrate why this is problematic, let's look at one bet that seems particularly non-robust to bad climate futures. That's here, the example here is avoiding tropical deforestation. So the primary approach right now to avoid deforestation is with international carbon markets, rich countries paying poor countries to not cut off their rainforests, essentially. Of course, if you're and this kind of can play an important role in it doesn't really work right now, but in a world that would be like 10% or 20% better in terms of international coordination, maybe this would actually work. But of course, in the world of 4 degrees or more, this kind of approach will not work, as the institutional framework, the Paris Agreement, etc., will not be intact. We're probably in a world of competition and low international coordination. So that's a bet that only works in the best worlds, and for that reason kind of prevents much less expected climate damage than we would think based on the expected emission saving. And kind of another bet that goes in the other direction as are bets that are made to hedge against, bets that are made to hedge against high emission futures. So here two such bets. One is kind of a bet on advanced nuclear on the left-hand side. The right-hand side is a bet on advanced geothermal. Both of those are technologies that may be, let's say, in the most optimistic future for wind and solar, where seasonal storage somehow becomes very cheap, transmission becomes very easy, etc. Maybe those technologies will not play a big role, but they are, of course, really important as hedging technologies, both to what is called renewable failure, which means like only 50% renewables, not 100%, something like that, and high energy demand growth. So yeah, this is kind of this important hedging function, even in the higher risk worlds. And what are kind of the generalized lessons we can draw from this? First, philanthropic bets should minimize expected damage rather than maximizing emission reductions. And this is not the same because of the shape of climate damage. And second, it's really useful if the bets that we make are robust or even solve key problems of bad worlds. So for example, making bets on geothermal, advanced geothermal, or advanced nuclear are just useful because one of the most likely ways in which we could fail is kind of if variable renewables don't continue succeeding extremely, like at an extreme pace, and then those things will be really valuable. What this kind of sums up to is focusing on what works when shit hits the fan. So what works in those worst futures. But, and that's another kind of lesson, and that's the more nuanced lesson here, this argument kind of has been prominent in EA's thinking about climate and kind of was very prominent under the Wagner and Weitzner probability, where kind of the risk of 6 degrees was more than 10%. We've now seen, okay, the risk is probably much less. So we really need to interrogate this, of course, all the time with new data on damage, new data on likelihood of scenarios to stay calibrated and see what the structure of climate damage is and how this kind of changes with further progress. yeah, with that, I'm kind of at the end of my talk. Thank you very much. Here's the way to get in touch with me, some further reading. And of course, this work is kind of always with the goal of making climate philanthropy better. So you can also support this work by supporting the Climate Fund, where we're trying to make donations based on analysis like this one to maximize our impact at the margin, given the structure of risk and damage. Thanks very much.
Great. Yeah, thank you, Johannes, for that presentation. Very amazing discussion of the often neglected tail end of climate danger, how to identify the tractable solutions to find those outcomes. And yeah, I think you guys submitted some great questions. We're going to try to get to them all. I think one question first from the audience is many statistics that you've cited are essentially from studies that look out to around 2100. And the question is essentially what do you think about the longer term risks? Like, for example, melting of ice caps, et cetera. Do you think these play a role in what you'd be evaluating?
So, they play a role, but they're not affectable, right? So if we're thinking about affectability, already kind of focusing on the rest of the century is kind of already the long end. I think my view is roughly that we need to reach net zero emissions as fast as possible. And if we're able to do that, then we're also able to deal with other risks and go net negative, et cetera. So I'm kind of, if that makes sense.
Yeah, great. Another question. I think just in general, what are some other examples of robust climate solutions or solutions helpful in severe outcomes that your team has investigated? Maybe what conditions or heuristics do you kind of follow in identifying these, given this risk structure?
Yeah, so I think there's actually a couple of answers here. So one is one also where I think my view have kind of changed, or where our views have changed. But I think things to be excited about from that risk structure. Two I highlighted. One is advanced nuclear. One is kind of advanced geothermal. I think another one that would be really exciting would be really cheap carbon removal. So it's not about the $100 plus direct air capture, because in the worst kind of worlds, we're not going to pay for that. But if we find something that we can do at $20 a ton, maybe that can still play a big risk reducing role. I think other heuristics or things where also my mind certainly has changed because of this, kind of looking into these things more, is technologies that require a lot of infrastructure or a lot of foresight. I've kind of become somewhat more skeptical of. So one example of this is, I think, carbon capture and storage, where I've certainly become more skeptical based on this reasoning, based on the reasoning that kind of in the world where most climate risk is concentrated, the probability that we spend decades building out infrastructure for a climate solution is probably less plausible. So that's kind of a heuristic, the amount of infrastructure that you would need. And I think the other is kind of, does it solve critical problems, or does it protect against critical failure modes?
That's a very interesting point. Yeah. Another question I think from the audience asks, do you think there are potentially better indicators for climate damage than GDP, for example? GDP, for example, other macroeconomic metrics?
Oh, sorry, I was muted. Sorry, just to be clear, for the damage, I would say yes, but also my main concern here was not with GDP as a metric, but with the shape of the climate damage. So I would kind of think more in terms of, for example, I don't really buy the percentages estimates of the integrated assessment models, but I kind of believe that there's this nonlinear shape, and those are kind of the things we should investigate. But absolutely, there are better measures, because a lot of the kind of climate damages will not be captured by traditional GDP metrics. So yeah, but I think it's a good approximation, of a first approximation to the question of the shape of the damage.
Yeah, definitely. Another question, this one regarding bets on the future. So someone brings up there's still a lot of disinformation denial problems even after decades of scientific consensus. Do you think there's any role for climate-based philanthropy to address that issue? Is that something that is being focused on?
So about climate denial? Climate denialism? Yeah. Well, I think it's playing less and less of a role. I mean, even in the United States, it's kind of its role is diminishing. So I think that's already happening.
Yeah.
I mean, obviously, like that would be kind of I mean, if you think about climate worst cases, I think that's probably like, okay, if you think about a 2024 Trump election win, and then like, okay, like if you kind of think this future forward, like that's probably gets you pretty close to the worst case. So like, yeah, having a climate denier in the White House, that's kind of scenario. Yeah.
Just one question on sort of like on the quantitative lens, I guess, of these interventions. But is there like some intervention you think, or based on research, that would be like the lowest hanging fruit in terms of like feasibility or like benefit from like spending money on it today? Or
I do think that the lowest hanging fruit right now is kind of to make as many, as a society, to make as many bets as possible on like lots of different technologies. And I guess this gives us a philanthropic kind of bet that we can make, which is kind of leveraging the policy advocacy organizations that are kind of trying to make innovation policy, energy innovation policy, more technology open, focused on a wider set of technologies, and kind of also leveraging this potential. So I think this certainly strikes me still as a very low hanging fruit in terms of philanthropic opportunities.
Another audience questions. Someone asks, what do you think about like geoengineering, and I presume other like large-scale engineering efforts to mitigate the effects of global warming in such uncertain or like tail environments?
Yeah, I think geoengineering is a really interesting example in this framework, because geoengineering, on the one hand, you would kind of want to use it in those worst worlds. On the other hand, those worlds are almost certainly surrounded by kind of international political conditions where you kind of don't want to use it, because like geoengineering, for geoengineering to work well, socially responsibly well, you would probably want to have the all major powers kind of behind it, etc., international cooperation. If you get in those worlds kind of the most severe climate damages are unlikely. So this technology or this approach kind of becomes less attractive because of this dynamic, I would say. And it's not, and we haven't included geoengineering in our grant making because we think first of all, we think politically it's very unlikely to happen, and if it happens, it's kind of going to happen in those relatively bad futures where it's not necessarily a good idea because of those concerns.
Yeah. Additional audience question. Yeah, someone asks, is there data that makes founders pledge more bullish on, I assume, carbon dioxide removal, or is it more that carbon dioxide removal is more necessary, so it's worth giving to various charities?
Sorry, it's more necessary than what?
Or it's just necessary in these kind of tail scenarios.
So I think the way that I think about carbon removal or making bets on carbon removal right now, which is what we're doing with like support for Carbon 180, is kind of trying to find, like exploring the space, because it's very, like there's lots of ways, like if you look at the literature on carbon removal, you'll find like lots of solutions that could have enormous scale and that could potentially be very cheap, but there's always extreme uncertainty around this. So I mostly see this as like, we should try out as many of those as possible. And yes, carbon removal will be necessary. I mean, the modeling suggests that you already need it for 1.5 degrees of warming at a very large scale. Obviously, here again, kind of comes this issue of like climate intention and warming, and like how likely is it we're going to use carbon removal on a massive scale in a 4-degree, 5-degree world? Maybe not that high. So it's probably more a solution for the lower warming worlds where climate policy attention is higher. But in those, it's I mean, there's not really realistic modeling that where you can get to 1.5 degrees without lots of carbon removal.
Gotcha. Yeah, another question. This might be a little outside the area of research, but do you think meeting emissions goals possible without like degrowth, for example?
Meeting emission goal, whether it's possible without degrowth. Yes, yeah. I mean, I do think it's necessary. I mean, I do think it's totally possible to reach. I mean, the question is under which time frame. So the question is like, is it possible to never exceed 1.5 degrees? Probably not. But probably it's just not possible anymore. We're just too close to it. But because of the possibility of carbon removal, we can always kind of reach this goal in the longer term. If there aren't like big feedback loops. And yeah, I mean, like, of course, whether or not degrowth would work is, I mean, someone can be very skeptical. That would be an entirely different discussion. It's not that we know that this is possible at all. Yeah, but it's not. I mean, climate change does not. We can solve climate change in ways that do not require degrowth, I think would be my answer. It's clear.
Yeah, certainly. Yeah, I think got a few minutes left, but maybe some wrapping up questions are like one, like what sort of next needs to happen, do you think, in this field? Like what skills or resources, for example, for better research, applying the takeaways here, do you think are like going to be most necessary over the next like few years for work on this?
For climate action more generally, or sorry?
I guess, yeah, for like the solutions you've been proposing, or like this kind of area of research.
Well, I think a huge part of the answer there is to like come to a more balanced climate conversation, and like also also have skills more broadly distributed. So I think right now, kind of a lot of the climate response is invested in just a couple of solutions, renewables, electric cars, etc. And those are like extremely critical parts of the solution, but those are also kind of the parts of the solution that probably don't need the most additional support right now. So like focusing on hard to decarbonize sectors, on some of those challenges that are not solved yet is where I would go. Yeah.
Yeah. And yeah, final question, I think. Someone says, great presentation, very dense. Is there a report that goes through this information in more depth, discusses the charts, etc., that they'll be able to use later?
Yeah, so two answers to this. I mean, kind of conceptually, there's our Changing Landscape of High Impact Philanthropy report from last November, which outlines all of the key arguments that I made today. But that did not include the data analysis that I've like now presented. So I wanted to update this with the new data that came in today. So I'm going to post something within the next month or so on the EA forum that kind of captures this in a long form. Yeah.
Yeah. Sounds great. Yeah, that's about all the time we have for this session. Thank you, Johannes, again for a wonderful session and your time with us today. As always, I think we invite everyone attending to use SwapCard to find fellow attendees to share your interests and set up meetings. We'll be doing a Gather Town Q&A after this session as well. And yeah, if you need any assistance with anything, please visit our SERI help desk on SwapCard. Thank you again for coming.